All right, kids. So today what we are going to learn is inverse function of trigonometric graphs. So when you're sketching, if you want to sketch inverse of a trigonometric graph, first of all, you should always remember we can sketch inverse graph only for one-to-one function. So what is the meaning of one-to-one function? One-to-one function means we can have one y value for one x value. So in order to sketch inverse graph, first step should be converting any graph into one-to-one function. Now you can ask, how can I convert any graph into one-to-one function? The simple method is by defining the range, defining the domain, not the range, domain. Now, what do I mean by defining a domain? For an example, let's say you have an x square graph like this. Now, if you have an x square graph in this format, in this way, now we know this is an one-to-one graph. Why it's one-to-one graph? We have, this is many-to-one graph. Why it's many-to-one graph? There are many x values for one y value. That's why we call it many-to-one graph. In order to convert this many-to-one graph into one-to-one graph, all I need to do is define the range of the graph such a way that it can be one-to-one function. There are two ways of defining the domain of the graph. If I say domain of the graph to be greater than or equals to 0, then my graph would be something like this. This is how my x square graph would look like for the given domain greater than or equals to 0. So if we look at very carefully, there is only one x value for its corresponding y value. Same manner, another way is simply by defining as less than or equals to 0. So if it is less than or equals to 0, the graph would be simply look like this. Now you can ask, but why do I need to know all of these things? The reason is that all of the trigonometric graphs are many-to-one graph or many-to-many graph. So first of all, if I want to sketch one-to-one graph of sin x, step number 1 is sketch the usual sin x graph. So the usual sin x graph would be something like this. Something like this. Now we can call this one as another type of graph. It can be the many-to-many or one-to-many. I have to first of all do what? Define the domain such a way that it can become one-to-one function. In this case, I'm going to define my domain from minus pi by 2 to pi by 2, which means that I'm going to extract the part of the graph only from minus pi by 2 to pi by 2. By doing so, I will get the graph of one-to-one function for sin x. What I'm going to do here is I'm going to simply extract that one-to-one region of the graph and sketch it separately. So if I take one-to-one region of the graph and sketch it separately, I'll just exaggerate the graph a bit. So graph would be something like this. this how the one-to-one graph of sine x would be look like. Okay. Now, if I want to sketch inverse graph of sine, all I need to do is reflect this graph. So this graph is sine x one-to-one format. If I want to convert, if I want to sketch the sine inverse, which means that arc sine x graph, all I need to do is to sketch arc sine x. Simply, I need to do reflect sine x, which is a one-to-one function on line y is equals to x. Simple as that. What would happen if I reflect a graph on line y is equals to x? If I do that for sine x graph, the values of sine x, which are critical values, pi by 2, 1, transforms into 1, pi by 2. Because when we are converting something into something into an inverse graph, there will be a swap in x and y values. So this is for f of x graph. This is for f inverse of x graph, inverse function. Same manner, minus pi by 2, minus 1, simply transforms to minus 1, minus pi by 2. As a result, the arc sine x graph would look something like this. Something like this. Here, the very important thing to remember, your arc sine x graph always looks like a x cube graph, a cubic graph. So this how the final graph of arc sine x looks like. So this is the graph of sine inverse of x, or we can call it as arc sine x. Now, there are one more important thing to consider. You can ask, but how do you come to conclusion it will look like an x cube graph? The reason is that technically what's happening is we are reflecting on y is equals to x graph, right? So let's say this is y is equals to x graph. And now my graph is getting a curvature for sine x, something like this. This is sine x graph. When I'm getting the graph like this, and if I'm reflecting on y equal to x, this portion of the graph would reflect like this, and other portion also reflect. And that's how I got this sine inverse to be very similar to x cube shape. Clear or not clear? For your convenience, you can remember it as simply x cube shape. Simple as that.